Okay, so a very, very short lecture to get us started on our input and output module. The majority of the time that we spend on this particular topic is going to be spent working on an associated lab. So in terms of lecture, it's very, very short. We're going to talk about predefined functions and some ways of formatting output so that we can get the output to look the way that we'd like it to look. So let's start with predefined functions, and these are going to be helpful to us in a variety of different contexts. And a function in and of itself is a subprogram or a set of instructions that accomplishes a particular task. And I would say functions different from a procedure in that a function returns a value. So main is an example of a function that executes when the program is run. Other functions will execute only when they're called. And C++ has a wealth of predefined functions that you can find in different libraries like IOStream, string, C standard library, and CMath. The header files will contain several different functions. And this is where a tool like C++ reference or Geeks for Geeks, as an online reference, those are terrific for telling you exactly what functions are in the header file rather than having us go over each and every potential function that you might encounter. So being able to reference those to get an idea of what functions are out there is a tremendously important skill. So if we want to call a function named func with no arguments, then we would just say func. If it had one argument, then we would use the command func followed by whatever argument or whatever information it needed if it just needed a single thing. If it had two, then we would separate them by commas. So again, we would say func and then give it the first value and the second value. And with three, we would use 2 commas, arg1, arg2, arg3, etc. So functions execute and then they return back to where they're called. Most functions return a value, and in some ways we want to capture that value, whether it's output or assigning it to a variable. So here's an example with the square root function. We would do pound include CMath, declare a variable answer that's of type double, and then we could say answer is equal to the square root of 9.0. And that will work because we've included the CMath, which has that square root function in it. So when we use these predefined functions, we need to make sure we include the appropriate header file. And that's, again, where a tool like C++ reference that's online is, actually much better than going over an exhaustive list in this lecture. You also need to know the function name, the number of parameters that are required, and the type of each parameter. And again, this is where an online reference is going to do wonders for you. I think there's also an appendix in the Malik textbook if you'd like to use that as well. And what type of value it's going to give back. That's the type of the return value in case you're using an assignment statement or want to format how you want to output. So, for example, POW is one that raises a number to a power, and it expects 2 doubles. So here we could get that from including CMath. We declare a variable x that's of type double and set it to 5.0. When we want to get x squared, we do POW of x raised to the 2.0. So x comma 2.0. If we wanted to cube it, we would do x comma 3.0, or really any double value to get that particular power. And that's how power works. The other thing in the first part of chapter 3 is formatting output. And so we've seen our cout already, and cout provides output to the monitor. And the companion lecture, we're going to look at how to do output to a file. The syntax of cout when used with the insertion operator is cout, insertion operator, expression or manipulator, insertion operator, etc. The expression is evaluated and the value gets printed. Manipulators are used to format the output. So for example, we could do cout 42 times 8 minus 2. That would give us some integer value, and put an inline, which is a manipulator, to do a next line on the output. One that's handy is fixed, and basically this outputs floating point number in fixed decimal format. The default is 6 places after the decimal, so we can do cout fixed, and we can do cout.setf ios : fixed. And that's the way I prefer to do it. If you want to show things in scientific notation, you can do scientific. You can also use cout.unsetf to unset the formatting. Precision is another one, and again, if we want to show things only up to a certain number of decimal places. So for example, we were using US currency, we might do that to 2 decimal places. Here we need to use IO manipulator, and then we can do cout.precision and give a precision. And that's the second way, is the way I do it. So if we do set precision 3 with 31.4159, the normal mode will give 31.4 because that's 3. Fixed mode will give 31.416 because there we're going for 3 decimals precision. And scientific will be 3.142 times e to the 1. So that will move it over 1 to the left. Showpoint forces the output to show a decimal point and the trailing zeros, and we do that by doing cout setf ios : showpoint. And so when you combine those 3, it kind of makes what Savage used to term a magic formula for getting things to display in 2 decimal places. So, for example, we do 3.0 with set precision 3, we get 3.00. Without Showpoint, we would get 3. And so it's not needed in fixed mode. There are other more advanced manipulators, one to line up output in columns. Feel free to look at these. You can find these in something like C++ reference or Geeks for Geeks. They're not required, but they can make your output for the programs look really nice. Thanks so much for watching.